Hi guys, and welcome to this first tutorial looking at the athlete monitoring dataset. For this tutorial, you will need Data1 and Viz1 open, and you'll also need the script open in SAS. So first of all, it makes a lot of sense to have a look at the data itself and to see what dataset we're working with. So as you can see, we've got several columns here. So we've got a player ID or a name ID column, the week and the weekday for the 13-week period that we used, a cumulative day, which is over the 91 days that were involved, a well-being score. This looks like a sleep duration, train load, so a sessional RPE for every session they did that day, and a dummy variable for whether or not there was a match there. And this is the raw data from A to H. And you can see as we go down to the bottom, we've got just short of 2,500 observations here. But you can also see there's a number of blank observations, so there will be there's a lot of missing data here. And knowing that this is a name ID or a player ID column, we know immediately that we probably want to be looking at a mixed model because there will be clustering around the participants. Now, columns I through N are processed columns. So column I just takes the mean of every individual's mean from their score in column F to give them a mean-centered sleep duration. Column J does the same for load. So the average load for player 1 was obviously 336 units because 0 minus 336 makes minus 336. So this is a mean-centered load column. We have then standardized that by 2 times the standard deviation for that athlete. So we have every single unit of columns K and L corresponds to a 2 within participant standard deviation difference. And I will explain that a lot more when we come to it. And then finally, columns M and N are grouped columns. So I have turned sleep and load into categorical variables, where variable 1 is anything that is less than 1 z-score below, that is more than 1 z-score below the mean, so -1 down to -10, for example. 2 is any value that falls between -1 and 1. And then anything over 1 z-score greater than the mean would be 3. And those numbers correspond to low sleep or low training load, medium sleep or medium training load, and then 3 would be high sleep or high training load. And you can see this data is in what we call long format, which means that every single observation has its own row. Okay, so if we plot that data, it looks like this. And we are plotting here the categorical elements, so whether we're in a low sleep, a medium sleep, or a high sleep. And on the left, we've got the wellness. And I'll be honest with you from the start, I'm working with sleep because it shows more differences than load, but later on we'll come to add in the load as well. So at the moment, there's not much we can glean from this information really. So let's start as we normally do with the null intercept model. And we can see we've got the covariance parameters like last time. We get an understanding of how many observations we're not using here. So there's about 450 unusable observations because there was no data available for them. The intercept is at 56.9, so our grand mean for the data is at 56.9 centimeters. We can see the residuals are quite nicely spread around the mean, although potentially slightly more below the mean than above it. And if I'm being honest, neither of these residual plots looks too great at the moment, but you'll see when we do the next model that it'll look much better then. So before we go any further, we can plot that null intercept again so you can get an idea of how little information it shows us. And there's a null intercept. So really we can't get any serious information from that this time. Now what we're going to do is we're going to run a random intercepts model. So we're going to give every player their own random intercept, and the only other variable that we're going to put in there is the sleep category. And that is this set of information, or set of code. Now, this looks like a lot of code, but it isn't really. Essentially, it's all the same as we've done before. We're going to put name ID and the sleep group into our categorical variables. Our only fixed effect is the Z group for sleep, and our only random effect is to give an intercept to each player. What we then have is we're going to focus on 4 players over the duration of this tutorial. And all I've done, as you can see, is I've obtained individual estimates for those 4 players. So we have the overall intercept first, the random intercept for all 4 players. Then this will give us the least square means for all the groups of Z group sleep. And pdiff equals all will calculate all the pairwise differences. So there'll be 3 pairwise differences between those groups. You can then see that we have got athlete 9's low, athlete 9's medium, and athlete 9's high sleep groups, and that what well-being score we'd expect for them. So we can take one portion of the intercept, one portion of the first group of sleep, which is low, and then we take one portion of adjustment of the intercept for athlete 9. This is the same, but our adjustment for Z group sleep is for the medium, group 2. And then we have the last one, last adjustment is for group 3, which is the high sleep. And you can see how we've done that for all 4 of the athletes. So let's run that now. Check the log, and there's no errors. So first things first, I said to you that the residuals will look a lot better, and they do. You can see how we're nicely spread about the x-axis now. We've got a pretty good normal distribution with the exception of a couple of outliers you can see here, and those outliers are also shown on the QQ plot. So there's an argument you could remove some of these, but we're just going to carry on with the analysis for now because it's pretty good. So looking at the results, you can see we've got 27 players involved in this, and there's 3 groups for sleep. You can see we've got our random effect for participant, and that's the between participant differences, and then the residual is the within participant differences. The intercept has centered itself at the high sleep group. There is a significant effect of sleep over as a fixed effect. And then the pairwise differences themselves are just underneath the least square mean. So these are the 3 pairwise differences that we asked the model to produce when we said pdiff equals all. And finally, in the estimates box, these are all the estimates that we asked for and that we're now going to use to have a look at the data. So first of all, let's see if the intercept position has changed. And the answer is no, not really. It's slightly lower. It is slightly lower, but there's no meaningful difference there. So we'll remove the null intercept and we'll add the means. So at a mean level, we expect the subsequent day daily well-being score to be low, to be lowest when we have low sleep and highest when we have high sleep. That makes sense, and it looks like a nice linear curve, a nice linear relationship that as you sleep more, you feel better the next day. But what we'd really like to tap into is understanding whether that changes for individual people or not. And the easiest way of doing that is to focus on a few of the athletes. So let's start by only looking at athlete 9. And this is all of athlete 9's data for the same 3 groups. And first of all, what you can see is that probably on the whole, you'd probably want the intercept to reduce slightly, but you'd also quite like it to be more diagonal up in this direction if you were doing the best kind of model for this participant. Of course, as we know, we can't do that with the model that we are currently using. All we can do is drop the random intercept and then use the same fixed effects from that intercept. And that's what we end up with here. So you can see how the intercept dropped, but the pattern of the fixed effects, so the sleep groups, is the same. And it helps, but it probably doesn't work as well as it could work for this individual. Next up, we can look at athlete 11. And athlete 11 is probably a little bit similar. So athlete 11 probably wants the intercept to drop down, but rather than having a greater slope upwards, this one probably wants a flatter slope. So let's see how that looks with the random intercept model. And you can see again how the reduction in the random intercept helps, but really there's no reason for this for low sleep here to be as low as it is in terms of the estimate. Likewise, the estimate doesn't really fit at high sleep. It should probably be a bit lower because this person's a non-responder to sleep, essentially. Next up, we have athlete 12. And you can see how with athlete 12, they have all of their values above the intercept because they generally have better wellness scores. So there's a strong argument that you'd want to have the intercept higher. And although the pattern of estimates for sleep groups probably works for this person, it may not be quite as sharp as it is for the mean level. However, again, all we can do with this model is put the intercept and then use the same mean differences. And you can see how actually it doesn't work too bad for this person. Maybe you'd want this one to be a bit higher, and probably you'd want this one to be slightly lower. So finally, we can look at athlete 13. And athlete 13 is all below the intercept. So we'd want the intercept to come somewhere down here, and actually the pattern probably wouldn't be too bad for this person, depending on where the intercept ends up. So let's have a look at that. Yeah, it's not too bad for athlete 13. But for the other 3 athletes, it's not particularly helpful. So why have I shown you this model from the off? And the reason I've shown you this model from the off is to show you that we can group data like sleep and train load and player load and a GPS metric into high, medium, and low. We can do comparisons between those groups. So we have got the comparisons between these groups here. And we can see that the difference between all of them is significant. So low sleep is significantly less than high sleep, medium sleep, and then medium sleep is significantly less than high sleep. But we actually lose a lot of information if we do that because we can't account for the fact that athlete 9 in particular could really do with a completely different slope on the intercept compared to the mean level. So we could really do with having a nice slope upwards like this. So in order to get that, what we need to do is we need to use a covariate within the model. And that is what we're going to do in the next video.